Hey folks, uh, welcome to another episode of the Common Lisp study group. Today we'll be going over, it will be the start of a few lectures on object orientation and the object-oriented features of Common Lisp. I'm your host again, Ram Vedam. We have our usual attendees today to discuss Chapter 16. This talk is going to not only cover Chapter 16, but a little bit of Chapter 17 also as well on object orientation, because to talk about OO without talking about some of the base features of classes inside Common Lisp, kind of, you can't really talk about O with Common Lisp without also talking about how to define classes necessarily. There are some features that are specific to Common Lisp that not only maps to, I would say, class definition, but they're often used in when you're dealing with classes in Common Lisp. So our agenda today is to talk a little bit about Lisp's object-oriented history. We won't go into too much detail, but it is important to know where it came from, because it will show sort of the reasons why Common Lisp's object-oriented system is a little bit different than the majority of O systems that people use today. We will talk specifically about the Common Lisp object system, which is what the entire OO system and its quirks are all, encapsulated around. That's what they're called. It's the full object system. There's a history around that name and what it does, and then specifically within this talk, and we'll hopefully get done within this talk, but probably will spill over into the next talk when we start talking about Chapter 17 on object with classes. We'll be talking about generic functions. To get things started, I think it's pretty well known, but I will say it here. The original Lisp, not specifically Common Lisp, but the original Lisp, which Common Lisp which is a successor of, it predates object orientation by a couple of decades. Object orientation, I would say, was created by, it started with Simula in 1967 and really took off when Smalltalk got standardized in the 80s. And there were a lot of different experimentations done with object orientation. So Lisp really predates all that. But that being said, a lot of different object systems were built on top of Lisp because of some of its driving features, of most of which is macros, which we've discussed in previous talks. But they took the entire object orientation paradigm and went with it. They made a they have a peculiar design that I would say, using other object-oriented languages such as Ruby, Python, or even C++, you will look at Lisp's object-oriented system, and some of it will look familiar, and some of it will look completely foreign. At least this is how I felt when I picked up the language and started learning with it. So I think you should, while comparing it with current object-oriented languages, you should compare it with the understanding that it took a different design approach than what most object-oriented systems did. And I think that's, and you have to keep an open mind on how it did things, because while it does make some things look a little too verbose, particularly in the cases of object invocation, method invocation, it does make it far more flexible to do certain things, in particular polymorphic functions, which we'll discuss as we get to it. So, as I mentioned, Common Lisp object system was a separate entity at first. It started off as a separate entity and then got standardized when Common Lisp was standardized. And a lot of things came with it. In particular, there were certain contributions that you may never touch, even though you're dealing with class. And one of those things is the meta object protocol that was built into Common Lisp. We won't get into too much detail in the meta object protocol in this talk, though I would we will look into actually figuring out ways of incorporating it, because it is a very interesting topic, especially when you're dealing with Common Lisp, because it allows you to define certain semantics of the OO protocol in such a way that you could really leverage a Lisp implementation that you're using and make really high performance code. Not to mention, it's flexible enough to allow you to try different strategies and research into how objects interact inside your particular application. But that being said, the base thing that almost everyone takes advantage of, and that it is there, is it does implement a full object-oriented language on top of Common Lisp. It's very similar in nature to Smalltalk's approach to Common Lisp. I mean, to object orientation, but it has certain semantics that are specific to Lisp, primarily because, and I'll get into this a little bit. It deals with unifying how we deal with method invocations with objects and how we do normal function calls inside Common Lisp. There was a new feature that sort of came out when they tried to unify those two approaches. But in a nutshell, and this would be familiar to most people, most Common Lisp actually follows most other object-oriented languages in that we are dealing with class-based objects. Objects are instances of a particular class, and a lot of the class itself determines the internal representation of the object instance. So, as an example, I give you a simple point class here, which has the notation. We'll get into more detail when we start really getting into inheritance, multiple inheritance, and so forth. But to really summarize this, is you have to declare an object, you have something called def class, much like the class syntax that you see in other languages. The name of the class. This list here that is currently empty represents actually the list of superclasses that this object inherits from. And right now, I just made a simple, top-level class that isn't actually inheriting anything from. Next, you will have what's called your member list or your slot list. Like, these are essentially, I would say, the equivalent of instance variables inside other object-oriented languages, although there might be other analogies here that if folks want to, who are currently like on the channel, who want to bring up other analogies to this, feel free to do so. But one thing that is specifically unique to Common Lisp is, at least whereas and this is not so much the case with languages like Objective-C, but definitely with other languages like C++, it has the ability to generate certain types of methods for you. In particular, you have what's called a reader method here, which is just like a getter in most object-oriented languages. You have also a writer method, and you have something called an accessor. And an accessor is really just a reader and a writer. You can read and write to that particular variable. Is there any else that I'm missing in terms of properties? Guys? Michael? Piano?
No.
Okay, cool.
Good.
So this is how you would really design a basic object, and we'll get into. You notice here, though, for folks, that this is just the internal representation. We haven't even talked about method invocation at all in this, and that's because you don't actually define methods in the class definition like you would in other languages. You have to you define them through something called a generic function. But in order to get into that, I wanted to actually get into a bit of the history of how this sort of approach came about, and that is, all of this comes back to Simula. Simula actually created, this concept of, behaviors are associated with classes. which are implemented through methods. And you call them instance methods in some books. You call them method member functions. Whatever you want to call them, it's basically object instances invoking a function call based on its internal representation. And this model of invocation, of course, is called message passing, which is based on sort of the Smalltalk terminology. So I would like to take a moment here to sort of really bring up, how Smalltalk do things, because this really sort of shows, because Smalltalk was a very big inspiration for Lisp's object-oriented system and how its features were set into the gaze. And I see we have Donald on, and I was hoping, Donald, that you could, Donald's our resident Smalltalker here, if you can sort of, shed some light into Smalltalk's, basic, object-oriented, like, paradigm and what actually, like, engulfs.
Okay. Some of the distinctions that into Smalltalk 80 were the result of what got culled out from Smalltalk 72 up to there to make the system a little more usable by humans. And so one aspect of it is that you have single inheritance hierarchy. So an object is a member of a single class. That class inherits from a single parent class on up until you get to the little the spiral at the top of the meta classes there, where it becomes self-referential loop. And I'll talk about that a little bit. Another aspect I want to mention is relative to like class single dispatch versus multi-dispatch, that for Smalltalk message send, the receiver of the message is determined solely by the single object that the message is being sent to. And what code is evaluated essentially is determined by that object's class and the class hierarchy. I know in class from the common loop stuff from InterLispD that it uses a multi-dispatch, which is basically a message send depends on not just the receiving object, but also could be the code that gets eventually evaluated can be influenced by the class of the arguments. So for an easy example, and I'm glad you have something up there, if you're just doing addition, then in Smalltalk, integer plus whatever results in the message being sent to the single chunk of code defining plus on, in the integer class. So you've got 5 plus whatever. That's going to result in a message being sent to, 5, which is an integer, and integer then decides what to do with whatever the argument is. In class, my understanding, correct me when I go astray on this side of things, if you're sending 5 plus 2, then really the two integers are going to determine what code gets evaluated. If it's 5 plus 2.0, you have a float, so that's going to determine what code gets evaluated, and that goes on in the plumbing of the system itself. Smalltalk, you have to actually write code in the integer class, because that's the 5, to say, okay, if the, use common term, argument that is, sent along with the message as an integer, then do this with it. If it's a float, do this with it. So you wind up building up lots of conditionals in the code, making it a little longer, less nice to read at times. That also goes in with the problem that pure object Smalltalk, you can't have a case statement, so you actually have to put in conditionals for all of the possibilities that you want to handle if you're handling more than one class of argument. Let's see. So part, I, I will ask, how much detail do you want about how?
So the basic idea is your message passing has really three different types, right? As of my understanding, which is binary messages, unitary messages, and then keyword messages, right? So, but the idea is still basically object, message, and then there's no concept of like function invocations in Smalltalk. Is that a fair assessment? Almost everything is just a message being sent to some object, and it will decide whether or not it will get handled. And if it doesn't handle that message, an error could actually occur, saying "message not handled" error. I think is what it was from. I was playing around with Squeak when I started learning it, so forgive me if that's not really the proper error, but that's the error I remember from it. So
yeah, method not implemented typically is set up to bring up a debugger so you can write the code there. Which is a common, a quick aside, a common practice for Smalltalk development is you intentionally, send a bogus unitary message to an object and bring up a debugger, and then you start writing your code to implement what you want the system to do because you just found where it needs to be implemented. And a lot of real development in Smalltalk environments happens in the debugger because you're just constantly, trying to do something that doesn't exist, and this is relying on the message sending aspect of it, and the system will find where basically what you want to do should be, and then you just create the code there. To address your point about functions. Functions are objects. So the idea of a lambda equivalent in Smalltalk is what's called a lexical closure or a closure, so that you can actually pass around code, in a message send. So, for instance, the way that a conditional statement's implemented, if then, is basically the true condition, you have a chunk of code that you want to evaluate within the current code context.
Mm-hmm.
And the same for false, you have a chunk of code. So in essence, you're sending that chunk of code, which is really a lambda expression. It's a function that's going to have potentially some parameters provided wherever the context is, wherever the code winds up, but it's also carrying context with it, which is the way that Lisp works. Essentially, you're happily moving code around, but that's the really the way that Smalltalk works in order to function.
Interesting. So the reason why I'm telling you this is, and I wanted you to discuss about it, is early Smalltalk systems. I saw this actually not only in Practical Common Lisp, but other Lisp books as well. Used to use this sort of syntax, which I will highlight here for folks to actually see, to actually send messages. And funny enough, when I was learning Clojure the first time, since we were talking about Clojure earlier today, Clojure had, to me, had also something similar too as well that I saw. I don't remember in what case that I remember that it was doing that. I think it was like if I was doing concurrency or something like that, I ended up using this kind of syntax. But this was, again, early on, like Clojure 1.0 or even earlier than that, circa 2009, 2010. Things may have changed in the Clojure realm from that time, but they had something similar when they would do essentially, okay, I want an object send and an object receive. I'll just do a send and receive on an object. I'll give you an object instance and then pass the method name and it'll send it. Funny thing is Objective-C also does the same thing. Objective-C underneath, every time you do a method invocation, also did essentially what's called an obj-C message send, which you pass in essentially the opaque data pointer representing the object instance that you want to send the message to, and then a function signature that represents the message itself. Now, one of the design side effects of this approach, if you're going to have a universal send thing that the Closs designers immediately realized, and actually Flavors, I think, also had the same gripe, is that, it doesn't look like a normal function. So you have to think about, different function call semantics, whether or not you're dealing with an object or you're dealing with a normal function itself, right? Additionally, this had also the problem, because of this syntax, of allowing you to do method invocation on collection of objects, which made it hard for you to leverage higher order functions. So you weren't able to leverage higher order functions until you wrapped your method call in a lambda and then used a lambda to actually call it, which obviously will sort of clutter up the code when you're just trying to do a simple function call. So the generic function was essentially their solution to actually unify both normal function calls and object methods as well. At least as I understood it. Obviously, the hyperspec may have gone into some other details, but this is based on my reading of Practical Common Lisp and other Lisp books, not specific to the hyperspec. It ended up this core idea, this generic function, ended up becoming the heart of how objects were implemented and essentially how polymorphic functions were implemented. It gave you the ability to not only design functions that worked on specialized objects and generic objects, but you could actually work on entire sub-hierarchies because the method lookup is completely separated. Does anybody have questions on this? Because this is important on an important point on how it's designed. And you'll see later where some examples that I will bring up based on what's in the book that sort of illustrates this. So to define a generic function, we have simply def generic. Def generic, anybody who's probably seen enough Lisp code now, it looks exactly kind of like a defun, except there is no implementation on it. I mean, I don't think there can be an implementation inside of def generic. Those of you who know that this is not true, correct me if I'm wrong, but I'm pretty sure that this is the case.
You can have methods, like you only have to have one method for a def generic. You get a better rate to the body of the def generic.
Yeah.
So you have a default. Wait, repeat that again?
Similar to how you can have a documentation entry in your def generic, one of the other options allows you to define a method in line. So you can actually define a couple of methods that are just part of the body of the def generic instead of as defining them as full def methods elsewhere in the code, if you want to do that. I don't see the style terribly often. Supposedly it can be more efficient in some systems, but I am suspicious of that premise.
Okay.
But you can, technically speaking, define methods inside the def generic form directly if you want to. It means that you have to redefine the entire def generic every time you want to update one of those methods, but,
Gotcha.
That's,
that's a whole ball. Okay, so that's a different set of issues if you wanted to, but technically the spec does allow you to.
And only accessible within the def generic context?
Say that again?
So if you're defining a method within def generic declaration, then would those methods be accessible outside of that scope, or are they?
Yeah. That just defines. So. Well, I guess we'll be getting into this in a minute. Sorry to jump the gun. Methods are just implementations of the def generic for particular types of arguments, right? And so when you define a method inside the def generic, that's the same thing as defining a method on that generic globally. It's just a way to put a couple of methods in one spot.
Thank you.
So, has Elijah alluded to implement an actual method, right? You would use def method to actually go and specialize a particular method here. So, like, let's take for example this example here that I got from PCL. We have a generic method. Let's say you're designing a banking application as it was inside PCL. You want to withdraw money from some particular account, right? So you can have a generic method on the account, which could be any account. Right now, we haven't even decided what type of account we're dealing with, and some sort of amount. And one thing to note is the importance of the documentation string in this sense when you are designing your generic functions, because you want people who are implementing this and who are specializing on the arguments to understand what the arguments actually mean, and it helps obviously document your interface, right? It will allow you to actually leverage that when you search through your Lisp implementation. Then what you'd want to do is let's say that you had a different types of banking accounts, whether they be checking with savings or whatever. You want to have a generic method that checks to see if our withdrawal is going to force us to do an overdraft or not, and we're actually withdrawing more than what is actually available. Right now, we can just throw out an error in this case. But what I want to show you, what I want to illustrate is when you do this, when you are specializing the method and the def method, what you do is you actually define the parameter, and you need to associate it with either a particular object or, and I've never seen this used, something called an equal specializer that allows you to actually check to see if your lookup matches the type arguments that the function actually needs. But the book doesn't go into. I didn't see too much detail as to the book going into what equal specializers are. So
equal specialization can only be done with EQL, the function.
Yeah.
And it's just a way to dispatch based on value rather than class. And while I mention it, I just want to point out that it's important to note that methods can only specialize on classes, not types. And that's important to note because all classes have a type of the same name, but not all types have classes. Like hash tables, characters, etc. aren't classes.
No. Pretty sure hash table and character both have a class. They have a built-in class. They don't have a class.
Right. So there is a difference there that I noticed that I would also want to bring up, which is what we call the primitive types or the built-in types. The built-in types may have what the book calls opaque representations that are only accessible to whatever functions that can leverage them. So like numbers, strings, I think they actually have simple vectors also. No, there was something else that I'm forgetting right now. Some primitive complex numbers are all examples of types that have representations that don't represent directly in class. At least that is my understanding.
Yeah, that's correct. Actually, the spec defines very few things in terms of class. Mostly because if for the most part, it hasn't really been necessary to define those types of objects as classes, because you just don't need the kind of flexibility that class would provide there. There are lighter weight tools that are part of the language, and also the spec more just didn't specify what representation internally a lot of the built-in data types have. Technically speaking, and actually I can go into detail here, like Steel Bank Common Lisp, for example, implements hash tables actually as a struct, actually as a Common Lisp def struct, which is so there's nothing technically stopping these, built-in data types from being implemented as structs or classes or whatever. But the point is that you can't rely on a particular representation. The data types that are provided by the spec are pretty much entirely abstract. They have what are called built-in classes, which are they function like classes as far as dispatch goes, but they don't have the same kind of metadata associated with them. You can't look at the slots of a built-in class. You can't, redefine a built-in class. But they have the same kind of dispatch properties. So you can define a method that takes strings, and you can define another method that takes, complex numbers and such. And that way you can, work with that kind of stuff. But they aren't classes specifically. This is one of those odd little things in how, class is in some ways sort of attached to the rest of Common Lisp, because the rest of the language sort of functions fine without having, classes and object-orientedness and generic functions, although it's very useful to have them. But it leads to these odd little edge cases where, since we haven't defined the semantics of particular things, you have things like built-in classes, which aren't really classes, but they work in a similar way as far as generic functions go.
So the built-in classes only are there to really to allow current primitive types, I guess, or primitive. Since I can't use types, primitive.
Well, actually, you kind of can use types there.
Okay, so it's primitive. It's to hook the primitive types then into the generic function machinery. It allows us to create specializations on specific types for user-defined generic functions. Right? Is that a good understanding? Okay, so
yeah.
That's a very important point though, because of the fact that it also means that not only can you use generic functions on, say, user-defined classes has respect to the Common Lisp object system, you can actually use generic functions on anything. Like if you wanted to write like like in the sense of like C++ and generic programming in C++ using templates, you can use that to create functions that work on specific classes of types that are already been defined in your Lisp system. If it has a built-in class, it'll just go ahead and specialize it when it's trying to call that generic function. That's a very important thing, I think, to at least mention, so that folks will be aware that it's not generic functions are not just specific to user-defined classes with respect to the Common Lisp object system. So this is what I was saying earlier about class. Like class adds some of these features that you wouldn't think that would be part of an OO style language, but are available in class because what it tried to do when it was unifying normal Lisp style function semantics with object method invocation. So I wanted to bring up this next example, which is, let's say now, because I was talking about overdrafting earlier and the differences between generalization and specialization. This example is from, again, Practical Common Lisp that specializes the withdraw method on let's say a checking account object, and you want to add some extra functionality before you actually call the generic method. And honestly, this is where I'll be upfront. My understanding of method invocation with respect to how class works kind of like breaks down, because this call next method, as I understand it, is just to force the Lisp implementation to invoke the specialized method first and then move up the call chain to the generic method. So it will start, like a depth first search to the most specific version of an implementation, invoke that, and then based on the location of where call next method is, it will go and call the next generic function up the tree to actually go and get invoked. Is that a correct understanding, or is there?
Yeah. So what happens there is so one of the rules about class is there's a well-defined ordering as to the class hierarchy, and this is actually getting back to something that Michael was bringing up, the difference between types and classes. Just to as a very brief aside there, Common Lisp's type system is much more flexible than the class system because types let you do things like or integer string or integers between 100 and 5,000. Those are types, but those don't have clean, easy to enumerate, easy to define the ordering for, in a class hierarchy, something that needs to be even more rigid as far as that goes. And so the trick is that the class hierarchy is sort of a subset of the type system in a way that enforces a strict ordering on, what classes, are higher up than others. And so since there is, multiple inheritance in Common Lisp, the rule, if I remember correctly, is left to right, is that although you don't need to know this in particular, the point is that the spec defines a well-defined ordering for when you have a class, for example, to work out the ordering of its superclasses in terms of specificity. And similarly, when you have a method or you have a generic function that has a group of methods, right? And it's just been called with two objects. It can look at the classes of those two objects, and there is a unique algorithm it can use that will take all of the methods it has that are known to be applicable to those objects and order them in terms of specificity. So you have the most specific one and the least specific one. And what will happen is it will call the most specific one. And then when you say call next method, that's telling it, go to the next most specific method in your ordering. Right, and then if that calls next method, that'll once again step one level further back. And so every time you call next method, you're stepping a further back in that ordering. There's also another function, next method p, which tells you whether or not there is a next method to call, which is useful when you're writing functions that, when you're writing methods that will get slotted in as like a mix-in. And so you don't necessarily know if there's a next most specific method, but if there is, you should be calling it. So then you can use something like next method p to check for that, and then call next method in a well-defined part of your method to get the next most specific thing, and possibly pass that out as your return value if you need to. So that's sort of how that all works. It's really that the specificity is determined ahead of time, always plugged into the system there, and then call next method is what lets a more specific method you refer back to a less specific one.
Well, it becomes important primarily because the chapter goes into method combination, right? And and method combination. This is where you'd have to understand specificity, right, with method combination, especially when you're debugging. And it's always like it was always a hard thing when I was picking up Common Lisp for me to wrap my head around, especially when it came to things called around methods, right? Like around method, before methods and after methods is just the ordering of where the call next method would work around. But where does around methods actually kind of fit?
So here's how that actually works, right? So
let me pop up an example so that people can actually see what we're talking about. So like let's say that we use in the book. Let's say that we're defining a generic function for like a batch processing system. We want to attach a priority to this system. So and we say that this is going to be a plus method combination. Okay, and there are plenty of method combinations.
Getting into the alternative method combinations.
Right.
That's its own bit of hairy mess. And
so let me try a different one. Let me try this one. Let's go back to what we were talking about.
Yeah.
Okay. So
what I'd suggest is instead
So let's say that we have something like this, or we also can do the same thing, except we could say that this is also after this, which is the same implementation for the sake of example. Obviously, you wouldn't do this in real code. But I think it's important to understand what the semantics of each style is, because there is a specific ordering that people need to understand between the three. Okay, so let me
so
bring this out of.
If you have this ready, go ahead, or I can take over explaining method combination.
Go ahead.
Yeah. So really, what it is so what we're looking here is what's called the standard method combination, or I guess you could say the default method combination. And the thing is, when I was saying before about Claus figuring out the specificity ordering of the applicable methods, that is a little bit glossing over details, I guess you could say, because there are actually multiple kinds of methods, right? And so the standard method combination defines 4 kinds of methods, and those are primary methods, which are the ones we've already been looking at, before methods, after methods, and around methods. And the basic idea really is if you have around methods, those happen first, and they work sort of just like the primary methods do. You hit the most specific one first, if I remember correctly. Well, I always have to check what the exact ordering is.
I think
generally speaking, if your around methods care about the specificity ordering, you've probably done something a little wrong, in my opinion. But because really the important thing is that they're around the primary methods, not the specific order that the around methods themselves happen in. Because if you're relying on that, you've probably got something messy. But the point is that the ordering for that is either most specific first or least specific first, and I can't remember which one it is. But the idea is it does that same ordering. It sorts them by specificity, and every time you do a call next method, it goes to the next one, until finally you hit the last around method. And then there aren't any around methods to, call anymore, and then it defers down to the handling of the before, primary, and after methods. The idea is that the before methods all get run, and they just get run in specificity order. Their return values are discarded. They're entirely for side effects. Then the primary methods get run as we described, the most specific one, which can call to the next most specific, which can call to the next most specific, and such. And then finally, all the after methods get run, once again, in specificity order. And so the idea there is this lets you, if you need to set up some dynamic context around the primary methods, for example, you can write an around method that sets up that dynamic context, and then the body of that dynamic context calls the next method. If you need to set up some, precondition handling, some check to make sure that code doesn't run when it's not supposed to,
you would use a before method in that. I would say you'd use a before method, right? In that case,
yeah.
Right.
Right. If you want to have logging for after something has succeeded, you could put that in an after method. And so the idea is that these 4 kinds of methods get combined using the specificity ordering in a very clear and well-defined way, and you can leverage that to write mix-ins that can very cleanly slot in extra behavior exactly where it's needed, and that lets you really take advantage of the multiple inheritance.
So, question on the around methods: is it actually implemented to just evaluate essentially one chunk of code as a before method and another chunk of code is an after method? Am I correct on the round?
Well, so the thing is, really what it is call next method, right? Returns the result of that next most specific method. It is actually a function that you call, right? And so really it's just that around, somewhere in its body call next method. And then that contains the entire rest of the computation. And then whenever that returns back up to that result of call next method. So the return value of the primary method, for example, would bubble back out to that call next method inside the body of the around function.
So the question I think he has, and this is where my confusion came in too, on around specifically, not necessarily before and after, because the before and after makes very, very clear ordering semantics, but with around, couldn't you, I guess, implement around before with a call next method, but with some dynamic context? I guess is at least that was the question I always had.
You can't actually implement. You can't actually firstly call next method in a before. Firstly, because the deferring to next method happens automatically with before methods.
Okay.
You don't actually have any control over that. All the before methods get run, and all of the after methods get run, if they get run at all. The around method gets to decide if the other methods get called. It can choose not to call next method altogether, anywhere in its body. And then in that case, it's deciding I'm not going to run any of the primary before or after methods. And so...
so you have more control in around methods than you do
Yes.
with
Yes.
with the before and after methods, because before
And the other side of it is that since primary methods happen from most specific to least specific, if I have a parent class and I need a method for objects that subclass my particular class, right? If I need all the primary methods, including any ones that the subclasses add, to happen inside the dynamic context that I'm defining with my parent class, the only way for me to do that is with an around method. Like with a primary method, the subclasses control the execution of the parent class's code, right? It defines the dynamic context in which the parent class's code runs. Anytime the subclass's method calls call next method, that is effectively a lambda that contains the entire rest of the call chain. And it's defining the dynamic context around which the parent class's code gets to run. But if a superclass needs to control the dynamic context around which child class runs, it has to do that in an around method, and then it's controlling all of the, it's basically stepped out a level, and now it's able to control even what subclasses would be adding in, assuming those subclasses don't themselves add around methods.
So it's funny you mentioned this, because the thing is the book, and again, this is why I bring up my confusion on this, is while I didn't see examples on this, the book explicitly says that the before method doesn't have to call next method to pass control to the main method, but it doesn't say that it can't call next method, but it just said that it doesn't have to call it. So
the before method, I believe, can't call next method. I'm pretty sure if you try to, Kloss will yell at you for trying to call
okay.
next method.
So there's an incorrect. Okay, so this is an incorrect statement, is what you're saying. If I follow the hyperlink.
Yeah.
Okay, gotcha.
It's
all right.
Yeah.
All right.
At
So,
the very least, it's a misleading one if
right.
it's not outright incorrect.
Okay.
It would be very confusing to try and follow the code if that was going on.
Yeah.
Right.
I mean, so I'm slow. Could somebody go through, if you have class A that has a primary method, a before method, an around method, and an after method, and a class B that is inheriting from A that also has a primary before, around, and after.
So you say you have a class A, all right? I'm just going to, write, and you have a class B, all right? Let's say that we have that, right? And you said that A has a method. Let's def generic.
B subclasses A.
B subclasses A.
Important.
Okay, got it. Okay.
Yes.
So this is important. I agree.
Yes.
So B subclasses A. Then let's define a generic here. Just call it A's method, some method. All right.
Sure.
All right, and then call it some object here. All right. And I'm not going to put a documentation string for sake of example, but let's say that it's in there. And you're saying, hold on, let me take this guy out so it doesn't confuse anybody. All right, and you say A has a before method, right? Some method before, and object is specialized on A. Is that correct?
Yes.
Okay. And def method, you have an around method, also specialized on A. And some method after. Okay. And you want the same thing but for B, right?
Right.
Okay.
And probably also a primary method, just for completeness sake.
Okay.
Yeah, sorry, I meant, yeah.
Okay, so I will add, so we have, so def method, okay, sum method. All right, and let's complete this guy by making this, sorry, meta adds replace string A with B, all right, and def method.
Around vector.
Oh yeah, I just noticed that. I just noticed that, but you know what? It's better to just change 2 than have to deal with 3, right? So, okay, all right. So these
also
are
round. You never add.
Oh yeah, I forgot. Yeah, I got it.
Yeah.
Around.
Yeah.
All right, good. So these are our 6 methods. All right.
8.
8. Yeah.
But
8.
yeah. Let's go ahead and actually evaluate all that if you don't mind.
Okay.
Just select all and evaluate region.
Shift and eval.
Slime evaluate region, probably.
Yeah, thank you.
Because if you just do evaluate region, it'll probably try to evaluate that on Lisp.
Has Emacs Lisp, right? So okay.
Yeah.
Okay, it's
So
all
there you go.
evaluated.
So let's go ahead and make an instance of A and make an instance of B over in the REPL and see what happens when we call.
Okay. Let's do def parameter main object instance A and make instance B. All right, so
Okay.
let's do some method on B, I guess. How would you? We'd have to show the trace of this, right? To show the order.
Right. Yes. So, there's a whole lot of different things you could do there.
I could do. Trace.
I've not actually tested exactly what SBCL does when you trace a generic function, but you could try that.
Okay, so if I do I specify a quote on this, a quote operator? I don't remember.
Don't believe so, but you
Okay.
can.
I'll just go ahead and then do it, and then if it complains, I'll go and
Yeah, no paren there though. Just do some method.
Some method.
Trace some method. And close paren and hit enter.
Oh, that's right. Okay, and then
now just call it.
Let's do. Do you want to do it on A or B? On B, I guess, since B is a subclass of A.
Well, start B object.
Okay. All right. Thank you. Okay. There we go. All right.
It does not show you. Does not look like it shows you the methods. Although I can't actually really tell because you've defined around methods that do nothing.
So let's say I'm gonna here. Let me add a couple things here. All right. I'm gonna add some prints. Okay. Print a method a class A method call. Okay. Let's do this. Class A before method call.
And make sure you call next method for the around methods.
Yes, that is important.
On you're talking about, yeah, okay, yeah, thank you. Print class A. I don't have to put this in a prog n, right?
No.
Okay.
No.
Okay, just want to make sure because all right. Do the same thing. Okay. And
This should be fine.
Okay, obviously I have to go in and reevaluate these guys.
Yep.
All right.
Oh, Control C, Control F. Huh. That's the standard key binding for that one.
All right. Okay, let's try this again. Hit this. So.
Oh, most specific around methods first.
Most specific around methods, then before methods, then the actual method itself, which is interesting. All right. Okay.
But note, Class A's method call was never reached.
Yes, Class A's method call. That's actually a very important thing, right? So you could actually.
You never call.
Yeah, I could do call next method right on this guy.
Yeah.
Right. Sorry, on B.
Yeah.
B.
There.
Call next method.
Next. Okay. Let's do that. Let's do this. There we go. That works. That makes sense. So if I change, that also means then if I change the ordering, obviously that should do like the same thing of what super does in like Java, right? Which is changes the method over, which I thought was
actually, if you note the return value actually from the two different calls, the first time it returned the string class B method call, and the second time it returned the string class A method call.
Right.
This time it'll return class B. And the reason is that call next method, of course, returns the value of the next most specific method's, return.
Right. So this gives you some control over the ordering. Now, this is a very simple situation because you obviously this means that even in any place that uses call method, you could change the ordering and it would affect the actual method, right? Like if I did this here, the same thing, not here, sorry. And actually, I could do it here. Let's say that I changed this guy and said this. Sorry, that. Okay. So let's see. That was around.
Yeah. Now the return value is class A around method call.
Yes, class A around method call is the last call to being called.
Well, it's because class A's around method has overridden the entire return value.
Right.
Because it sort of discarded whatever call next method returns and returned whatever the print returned.
And it's because again though this call next method is returning the last function eval, and then we had one more yet again that's going to be evaluated afterwards. So this is the last thing that's going to be returned from the call chain. So so some lessons here, right? I think that should be brought up is call next method gives you some very nice control. There is some semantics that need to be considered when you're dealing with around methods and after methods, but it is a very strict ordering. You can, as you can see here, what the order can be. You guys want to add anything?
Yeah, you can actually change the order and flip it so it's completely reversed.
Yeah,
you can specify the default ordering is most specific first. You can change it to most specific last. In the def generic specification.
Yeah. I forget what the option is for that because
That's
never
why
use
I
it.
never superclasses and subclasses because it all depends on the generic function.
Yeah.
But this brings up also some of the auxiliary stuff because actually it's funny you mentioned that, Michael, because he talks about most specific first and most specific last when he's talking about the alternative method combinations like the plus method combination. So in his example, in the plus method combination, which is just adding functionality, if I'm that have side effects, unless the object has side effects.
So they're what are called the simple method combinations, right? And so plus is one of the simple method combinations. And the idea is that basically all of the applicable methods get run, I think, in most specific first order to least specific first, if I remember correctly, although I forget offhand.
Yeah, no, that's right. And then what you can do if you want to change that, you can actually do most specific last, as shown in this example.
And then the idea is that for all the simple method, combinations, right? They're sort of named by the function that then gets used to combine all the return values together. Function or special form.
Right.
I always forget the prog-n method combination, which I find the strangest one of them all. But I mean, I suppose it makes sense. But well, the point is that, like, for the plus method combination, all the methods are expected to return some number, and they all get added up.
A good example would actually be to use the prog-n method combination, because addition is so.
Okay, so let's try this. Let's bring up a quick example here that we could come up with using the same classes that I had earlier. Let's say that I created generic here called some prog-n method. All right.
Oh geez, now I got to go look at the syntax. It's been a while since
I just looked it up.
So let me put a documentation here so folks who are watching this can.
And then after a documentation, you want to add a method combination form. Say keyword, just like documentation.
So you do method combination, you do prog-n, and then you. Right?
Is that a symbol or a keyword?
It's a keyword.
So I could do.
No, that's a symbol. That's
okay.
So I have to do this, or is it already a symbol? This should be already a symbol, right? Because it's already.
Yeah, that should just be a symbol.
Okay. Yep. So I could just do that.
And that should work.
Okay. Okay, it worked. All right.
And you also have to define your methods to use that same method combination.
Right.
Right. Yeah. So similar to how you can put before, around, and after as a qualifier for methods. When you have a method combination, when you have one of the simple method combinations, you have to use the name of the combination in your method signature.
And that is a keyword.
So this guy
is
this. Okay, got it. All right, that makes sense.
That's where I got confused.
Yeah, that's one of the weirder bits of the spec. There are a few weird bits of the spec, more than a few weird bits of the spec.
But this is useful if, like, your most specific method you want called last, so that you can override functionality, basically.
Okay, so you could change the order and make the order anything you want to if you use the prog-n method combination.
Prog-n is going to call all the primary methods.
Right.
And the return value is going to be the last one.
Okay.
Yep.
So
it's basically just the functionality of the primary methods from the standard method.
And the last one being your most specific one.
Right.
Okay. So.
Well, I mean, if you do most specific last.
Yeah.
Yeah, I didn't put most specific last now, but I could.
That's a good thing to use with prog-n a lot of times.
Okay,
yeah,
so let's do that.
So
you'll say most specific last. Because right now I didn't have that.
The really crazy thing is you can actually define your own method combinations, which I just find to be amazing that they decided to put that in the spec. Like, that's mop magic.
That is mop magic. There's a lot of stuff with mop magic that I think would be pretty cool, because especially if you wanted to create.
Well, no. Defining your own method combinations isn't mop magic. That's in the spec.
That's in the spec. Okay.
Yep,
Never mind.
Say define method combination.
Yeah.
Macro.
Yeah, and it lets you. It's crazy. That's one of the most complicated macros in the spec, in my opinion.
So
that one rivals loop.
Let me see what happens if I do this. I mean, it said the last method. Okay, so I do B object. No standard applicable method. Oh wait. I think I forgot a prog-n. And
you didn't act. Oh, your second method is named wrong.
Oh, dang it. Okay.
Actually, they're all.
Yeah. I saw it.
So here's one of the little things. This is why it spit out all those warnings when you compiled that originally. But part of it is that you don't. Oh, also SOM. No.
What? Wait, what?
Your second method is still named wrong.
I forgot. I had a typo.
Yep.
Dang it.
Yep. There you go.
Now I'm good. All right.
Control C that one.
Yeah, I'll just.
You should be good.
Yeah, Jesus, man. This is why you don't do live demos a lot. All right. If I run that, invalid
It still
error.
doesn't like it.
Let me see here.
Has an invalid qualifier. Oh, yeah, no, it's not a keyword. It's not a keyword.
So
I don't know why we thought it was a keyword. It's not a keyword.
So this is.
It's never a keyword.
So this is.
What am I thinking?
Yeah,
Okay.
I know, right? I thought it was a keyword too, but no, it's just the other one for which it's a keyword.
Shows how
That's
much
why.
I use this.
Oh no.
The method combination progan was defined with the short form, and so requires.
And so it requires all methods to have either the single qualifier progan or the single qualifier. Oh,
around.
because they're now redefine that. So go with that. Yeah, kill that. Okay. Inspect. Do you know how to invoke the inspector?
Yeah, you're talking about inspect which.
Inspect the method, the generic function's name. Yeah, inspect the name of the generic function.
Okay. Oh, sorry. I have to go to that. Hold on. Yeah. I think it's Control C.
It'll be simplest just to do it this way.
Oh, hold
just to inspect that if you can.
Yeah, hold on.
Personally,
I'm forgetting
I'm a fan
right
of
now. Inspect.
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 Yeah.
That's it. Okay. Yeah, that guy. It's unbound.
No, hash tick. You need a hash tick in front of it.
Oh, okay, got it. Okay. Slime inspect. This needs to do that. All right.
Hash. Yeah, but now go down to the it is a function line.
It is
right?
a function.
So
okay, I see it.
Yeah, hit enter on that.
All right.
Okay. Yeah. So, just remove all of those methods. Just remove all of them. Honestly, just remove all of those methods.
Okay.
None of them are useful to you. 2 of those are the keyword ones, and 2 of them are the simple ones. And it won't show you in here because it's weird.
Right.
So Q to exit out of that.
Q. All right.
The problem is that methods, that differ by their qualifiers are different methods, and so it still had the ones that were using the keyword.
Okay, I see what you're saying.
That was an invalid qualifier.
Okay,
So,
now this works. Okay, so
yes.
First, I learned a few things here. Now, everyone who's watching the live stream, you guys learned some interactive debugging here. You can change your entire Lisp image by just going and inspecting the object and removing the object.
The inspector is extremely useful for when you break things.
Donald, as you can see, this is very much like how you'd use the Smalltalk debugger, too, in some sense.
Yep. Inspectors and
Yeah.
Yeah, no, the Lispers learned a lot from image-based development with Smalltalk. Like, we do have a lot of.
We owe a lot to how some of this.
I would say it's fun how much went both ways. The whole Smalltalk virtual machine bytecode stuff was actually a lot came from InterLispB from Holt, Berniak, and Newman. Their Lisp implementation and like Danny Bobro and all went from BBN out to Xerox PARC, and then Peter Deutsch and Bobro and folks doing stuff at PARC, and then Deutsch implementing stuff in Smalltalk. And I would challenge anyone to really get down to exactly what came from which side. Really, I mean, in a sense, that's the beauty of it, is that there was so much, to borrow the artistic term, stealing, steal. There was so much stealing going on that everybody was happy with it.
Yeah.
And, unless getting into a really pedantic rant with somebody who's so stuck on one side, I'm happy to take the other side, devil's advocate on it. But the Lisp and Smalltalk really, it's neither would be where they are without the other.
Yeah.
And I agree with you. We're slowly getting back to the kind of incremental development style that they pioneered. and we're nowhere near to some of the kind of redefinition stuff that.
Well, I mean, that's the whole thing. 20 years after it was invented, then people actually start doing it, and then another 20 years, and it becomes common practice and whatever. But I just keep looking at that, and Lispers and Smalltalkers both go through the same hair pulling, seeing the agile development and stuff going on.
Oh.
I remember doing that, just sitting at shared office space desk with somebody using Smalltalk, and the same thing with up at Lisp machines up at MIT and other stuff. That it's like there's not a whole lot new.
Yeah.
You're just sitting back and enjoying the ride, right?
I would say that's one that gets attributed to the Smalltalk side because of the the folks who actually brought it into common software practice were Smalltalkers, but it's rubber ducks have been around for a long time.
Yeah.
Oh man.
Just to finish the basic overview of class, do you want? I mean, said that you weren't very familiar with EQL specialization. Do you want to just you want me to run you through that really quick?
Yes, please. I mean, I think it's important for folks who are listening, especially.
That's very common to do value dispatching rather than class dispatching. And it's pretty much everything else we didn't talk about yet.
Yeah. So in this case, like if you wanted to do like the example that they gave in the book, and I think that's a good one to go through so people can go back and review it. On value specialization, EQL specialization was related to. Hold on, let me just pull it up because I had it here just a second ago. Here we go. Boom. All right. So going back to our withdraw example, and those of you who are, on the live stream, I will go ahead and post this on the Atlanta Functional Programming GitHub page, and I will give you guys a GitHub repo URL so you guys can look at this code. It's some of the examples that we did with method combinations, as well as some stuff that was extracted from the book, but it will give you a nice thing to look through. But in the book on EQL specialization, we were going back to the withdraw example. They used, like, let's say we have a our account that's associated with some bank president, right? This, I think, is what they were saying about EQL specialization, right? They are looking at the type that's being passed in, right? The instance of the type that's being passed in, and they're looking at this default templated parameter that you're using to specialize this method on. And if they match, it'll get invoked. That's essentially the idea of EQL specialization, right?
Yeah. I mean, you're looking at at any arbitrary object and its value to do your specialization. Instead of matching a class name, you were matching the value of whatever something gets evaluated to.
So it's explicitly the value, not the variable itself. So no type information at all. So if only this value is so I'm trying to come up with an analogy.
It only does it with the comparator EQL. You cannot do like list comparison or something that requires like equal P or even equal.
Yeah. So part of what it is that specializers are a bit more flexible than just specializing on class. The only two that are defined in the spec are EQL and the standard class specialization, and those are the only ones that you'll really see in practice. But the basic idea is just that a specializer basically just limits the applicability of a method.
Right. And let me interrupt you there and just come up with this question, because honestly there is no real clean analogy for this, because this is looking at a running instance, right? You're adding essentially something that's already been bound to a value and saying, okay, by the way, on top of this base methods that I'm adding a couple of methods on top of this guy that's already been instantiated, right? I mean,
yes.
And
yes, although it doesn't. It's not just for like instances of class classes. You could, for example, define a method that dispatches on an argument that's going to be a keyword and have methods specific to which particular keyword got passed in. For example.
All right.
If you wanted to do that, you don't have to use class with, you don't have to use classes with, methods.
With methods. Okay.
Generic functions. Also, like another thing is that like just as there are built-in classes for all the standard, types, all the standard objects, any objects that you define with def struct, for example, which I don't know if we've covered def struct a whole lot on stream, but
we have not yet covered def struct, but since we brought it up a couple of times, I think it's important to go ahead and cover it.
Yeah. So def struct is it's much lighter weight than class. Like with class, for example, if you redefine the slots of a class while there are existing instances of that class, it's perfectly fine. Class will figure it out. It'll go find all the existing instances of that class, and it will do its darndest, and there are in fact ways you can override its behavior if you know something better than what the standard does. It will do its darndest to figure out how to reshape the existing instances to conform to the new class definition, and it'll just keep chugging along. Like, class is kind of crazy in that regard. It's, you have a static set of members, but, if you change the set of member variables or slots of an object, it'll figure out what to do. Not so for structs. Structs are, you define them once and then you never redefine them ever. Because if you redefine a struct...
So if you do, like, XY, like we were talking about, if we do XY here, like, for example, for a point, and if we define this, now if I add XYZ, you're saying that this will complain? I mean, if I added this.
Yeah, do that.
Okay, so if I do that,
it's
and it complains.
Specific on what it will do.
Yeah.
And it says, attempt to redefine
structure class point incompatibly with current definition. Basically saying, you're an idiot for trying to do that unless you really know what you're doing. SBCL, specifically, has gotten pretty good about not, crashing and burning when you do this.
Right, and that's the reason why they have this option called recklessly continues.
Yeah. So, like, if there are no existing instances of that struct, and there are no existing instances of that struct, recklessly continue. But don't, please. Unless you really know what you're doing and you've done this before and you're perfectly happy with having to possibly reload your entire image because you screwed that up.
So, in this example, I can go ahead and do it, but they'll warn me again if I try to pull it.
If you redefine that struct with this exact definition, right? If you recompile that, that's fine.
Right.
Right, because it's a compatible definition, and SBCL is okay with that. But in practice on other implementations, who knows what'll happen?
Right.
And like one thing is that SBCL I know actually changes how the garbage collector works. Right, when you define a struct, when you define a class with class, it can't be that willy-nilly about how it sets things up. But when you define a struct, SBCL doesn't record the garbage collection information in the object or in any metadata that the garbage collector will go hunt down at runtime. It actually informs the garbage collector immediately that any time it sees this struct in the future, just, scan it for pointers this way, right? And so if you redefine a struct improperly and there are existing instances, the garbage collector may no longer know how to scan those existing instances for the pointers that they contain, and now you might have, random garbage floating about your image, or worse, a corrupted garbage collection phase. And, that's all kinds of stupid crazy, right? And so basically never redefine structs.
Yeah,
structs are...
Just don't do it.
Don't use structs. Don't use them at all unless for some reason you need, like the two cases where you should be using them, which is like if you wanted to define a struct that represents an array, you can actually make an array with named accessors. For example, like you can name Instead of accessing an array by index ID, like by integer, you can access them just like a regular function, and it will compile down to the same disassembly code.
Right. So yeah, you can. One of the things you can do.
That's highly specific. I mean, you should never use a struct unless you really need special stuff like that. Never.
Yeah.
Interesting.
I mean, I personally, when I'm hacking around, use struct more often than I probably should, but I know the dangers, and I'm not usually expecting to come back to that code later. So,
but Ram, your
right.
method, or were you?
I did actually have one of the things I was getting back to though, which was that when you define a struct, it actually defines what's called a structure class. Right? There are actually a couple different kinds of class in the system. There's there are built-in classes, there are class classes, and there are also structure classes. This is another one of the kinds of classes we have, right? And so you can still do generic function dispatch on structs, for example. They do have a class as far as class is concerned. And so if you never ever want to use classes for some reason that completely escapes my mind that I cannot understand, you can actually just completely avoid them altogether. And if you need custom user-defined structures, you can use devstruct for them. But don't do that, because it's silly. There's no point. My point is more just that, class is well integrated with the rest of the system. Whenever you're defining a new, structure or a new type, generally speaking, class will know about it, unless you're using def type, which is really more for defining a type alias, and that's something that, that can use features of types that class simply doesn't have a way of dealing with, like and types and or types and integer range types and nonsense like that.
Right. And I think types deserve their own own discussion, because honestly, the type system in Common Lisp is something that's often ignored. There is a type system, though. There is a type system, and it's something that is never discussed, but it's there, and people should know about it.
Common Lisp has the odd distinction of being a language which is strongly dynamically typed and weakly statically typed. Not many languages have that particular distinction. Common Lisp is one of them.
Right.
I don't know if I really like it, but occasionally it's exceedingly useful.
I will, and again, we're running out of time here, but I will say that, to end this particular part of our discussion is that the type system is something that's often ignored, and it's there, and it will help you if you know how to use it. And I think that will be essentially a point for a future discussion, and I will bring it up again, because it's something that should be at least discussed so people are aware. Michael, you had yes.
Would it be fair to characterize the structs and use of them really being more just for an optimization?
Yes, actually.
That's a very good comparison. Yes, it would be kind of an optimization.
Yeah, you can pretty much entirely remove the overhead of structs altogether if you want to. Like you can tell a struct, no, Common Lisp, don't record runtime type information for the struct. Implement it internally actually as an array and record its type as being an array, and make all the accessor functions just be specializations of calling the array dereference function for this particular type when I've statically defined the types of all the members, etc., etc., etc. And, if you define all of that in your devstruct form, the overhead of the struct itself completely vanishes. It is, as they say in the Rust world, a zero-cost abstraction. But it is hostile to live coding in a lot of ways. And so only use it if, you're writing a math library and you know what you're doing.
Right. I think that's probably the only use case.
Which is the only time I've ever used it when I wrote my math library.
Right.
That's the only time I've ever used it. Well, besides just messing around in the REPL. But don't use structs unless you really need them.
Right, and I think that's a very good point, though, right? When you're writing numerical code, there are features in Common Lisp that allow you to write really good numerical code, but don't use them generically, because it could lead to other, problems in the long run, and especially if you're doing live development.
Fast code and lively reloadable code have always been kind of at odds. This is always...
So, that touches on one other itch I wanted to scratch with,
Sure.
yeah, the Common Lisp experts, which is on the actual method, invocation, call, dispatch, whatever you want it.
Sure.
How much or what is the optimization like under the hood for that? Because I understand pretty deep down in the, on the Smalltalk side of it, inline caches and stuff for that. But I was wondering because the Common Lisp environment around methods and everything is a lot more complex. So I'm just wondering how much.
Method invocation has a pretty high overhead. Usually, that far outweighs the performance you would need. Convenience usually outweighs it, especially during live developing. But there is a runtime dispatch cost when using generic functions.
And it verifies a decent. It varies a decent amount. Like if you're just dealing with primary methods, for example, SBCL is remarkably clever about caching that kind of stuff. And so if you only have primary methods and you don't have a lot of subclassing, the overhead goes away pretty quickly. It's not that bad. But when you do start dealing with around methods and before methods and after methods and method combination, there is caching that happens in there. Some implementations are cleverer about it than others. SBCL, actually, probably one of its weakest areas is in intelligent caching of method combination and class optimizations. Some implementations like Lispworks and Allegro are known to actually have very efficient class implementations.
Very efficient class implementation. In the case of Allegro, I can attest to that because I've used Allegro in the past, and I've tried some of this before, but I've never quite understood why it works so damn good. So
another part of this, right, and this is where it gets kind of weird, is this thing that we may someday get into in more detail, which would be the meta-object protocol. I brought it up a while back, the MOP nonsense, which is that, a Common Lisp's object system is one way to think about it, because bootstrapping and all, it's not actually how it happens. One way to think about it is Common Lisp's object system is defined in terms of itself. And so there's a generic function is a class, and standard class is a class, and you can define your own meta classes. You can define your own meta objects, as they're called, things that subclass, funcallable standard class, and stuff like that. And you can redefine how specialization happens for methods. You can define your own method specializations if you really wanted to. Although I've only seen that in a couple of academic papers. I've seen people defining custom method combinations.
I think just to point this out, you have to realize at least the meta object protocol that's in Common Lisp, right? At least the details of it weren't really published until the mid '90s. By that time, a lot of the interest in using it in Common Lisp sort of kind of died away. In fact, Gregor Kozelis, the guy who wrote Aspect J, he took all of his work on the meta object protocol, because he actually wrote the book on it, The Art of the Meta Object Protocol, and he put it into aspect-oriented programming, which is used a lot in Java, especially if you use web frameworks like, say, Spring. So I just want to bring that up because that piece there about it not being used or not documented except in academic papers, it's not that the work or the ideas haven't been prolifered into other languages. It's just that
actually, as a side note there, although you're right, I don't see a lot of MOP usage in practice. Specifically, method combinations was the one that I was referring to there. To emphasize that point. I do see actually a decent amount of meta classes defined, custom meta classes defined. I've come across a couple of implementations of transactional memory in Common Lisp that work by defining a custom meta class that allows you to have transactional memory on the slots of instances.
Right, I've actually seen that too. I've also seen it used in persistent meta classes, especially if you look at libraries
Or,
like Elephant.
Yep.
Elephant actually uses it quite a bit. Elephant is, by the way, folks, an ORM style framework for dealing with databases inside
Yep.
Common Lisp, and it actually makes
It
heavy
uses the
use
mop
of-
pretty heavily.
Yeah, very heavily.
Yeah, yeah. But my point was more for optimization's sake.
Yeah.
SBCL, the performance of the mop is admittedly kind of terrible. Well, the other side of it is, though, that it depends on what you're looking at, right? Because if you're comparing against, like, method invocation on, like, in Python, for example, right? Python's, system is not nearly as complex as Common Lisp's, and I can almost guarantee that Common Lisp method dispatch is more efficient than Python method calls. I can almost guarantee this, right? Because Python isn't designed for speed, but you can still get a lot of done with it, right? You can get a lot of stuff done with Python, leveraging, the abstractions over lower level functionality that it provides, so you can have these very high level tools, these very flexible tools that rely on these much more efficient lower level operations, right? And so the overhead of methods isn't actually a big deal in my experience. It is not great, admittedly, and though some implementations it is actually remarkably low. The anecdotal evidence I've heard is that on implementations like Allegro and Lispworks, you can pretty much use the mop without having to worry about the performance costs at all, despite the fact that it's implementing things like method combination in terms of method calls. But SBCL specifically, that's one area where you want to keep an eye out. But on the other hand, SBCL is extremely competitive in writing lower level code when you need to and you really care about the efficiencies there. So if you have extremely, CPU intensive algorithms, SBCL really allows you to work the optimization kinks out of that instead. And so while your higher level code is a bit slower, your lower level code is a lot faster, your tight loops can be a lot faster, it varies on what implementation you pick. But, it'd be great if we had the best of all worlds in one implementation, but
Right.
there's only so much developer hours to go around.
We went a little over today, but this is a great discussion, and honestly, we're going to have to continue with this hopefully next week on this because we haven't even touched how classes kind of work. But until next time, meet us next week when we actually go through classes because all this information is the precursor to how you would end up really leveraging them when you're using classes themselves. So till next time, let's read Chapter 17 on object reorientation, which goes through classes in Practical Common Lisp, and let's touch base then 5:30 to 7 in the virtual world. I'll see you guys later.
See ya. Bye.